All right. So just a quick reminder on my phone, I'll have the Discord lecture channel open if you want to ask questions during lecture. For the, because that's all 116 stuff. There was the question, now I forgot the term. The other, instead of port forwarding, what was the other one? Port triggering. So I did look that up. It's a way to do like dynamic port forwarding. So each machine on the network can request port forwarding on a temporary basis. So it's a more versatile way of doing port forwarding. So I will have that open if anybody wants to ask questions on that, or just do the old-fashioned raise your hand. So let's talk about the homework a little bit. We are getting to the point where you can start completing some of these objectives. From what we did last time, you can complete objective 1 minus the Docker part. You won't be able to do step 1 running in Docker, but you can run the same testing procedure while running your app outside of Docker. So if you're using Node, just run it using Node or Python, whatever language you're using, Scala, just run your server in that language and then test it doing the regular testing procedures. You can still do that. And then once we add that layer of Docker on it, we'll automate the running of your app. But we haven't covered how to do that yet, so don't sweat it yet until we get to the Docker lectures. Today we're going to cover how to do Objective 1 more in depth. Last time I kind of gave you a very quick overview of HTTP. Now we're going to start dissecting HTTP one topic at a time. Today we're going to look at the structure of a request and the structure of a response. We talked about it last time. I did mention all the parts last time, but we want to go into more detail about that. Some new content that we're going to cover today is 301 and 404 response codes, what to do when content isn't found, and what to do when you want to redirect the user to a different page. And then we won't get to objectives 3, 4, and 5 until later lectures. But after today's lecture, you'll be able to do objectives 1 and 2. So just a quick roadmap of where we're at in terms of the homework. And then starting on Friday, you'll be able to use Docker. You'll be able to apply Docker and completely complete objectives 1 and 2. And then objectives 3 through 5 will be Monday and Wednesday next week. With that, any questions before we jump into some content? Let's do it. Oh, come on. I don't want a slideshow. No, not that one. And they're both F. Ah, come on. So I have to remember the keyboard shortcut for that. I'm not going to do that today. I'm just going to enter full screen. All right, HTTP request and response. So, oops, I actually wanted to go to the website before that. So when we start talking about HTTP, and as we start talking about a lot of these protocols, each one of these protocols is going to have an RFC document for it, which is a request for comments, which is pretty much the way internet protocols evolve and the way they are formed. The authors put out a request for comments. Everybody can comment on it, and then that document eventually becomes the standard. It becomes the spec, it becomes the protocol. So the RFC for HTTP is RFC 2610, and this defines everything about HTTP version 1.1. This is what HTTP 1.1 is. It's this document. Nothing outside of this document is HTTP, and everything that is HTTP is inside of this document. It's completely comprehensive. So whenever somebody's writing a browser, they're going to look at this document and comply with this, hopefully, and comply to what HTTP is. And whenever we're writing our servers, we're going to comply with this, comply with what HTTP is, and then as long as everybody's coding exactly to this document, the browser and our server will be able to communicate effectively. If you ever have a question, if I ever don't go in depth as much as you want in one of my lectures, if you ever want to go beyond, especially if you're out in your career and you have a question about HTTP, this is the document. This is where you look for the definitive answer. You can try searching, you can try getting Stack Overflow answers and blog articles and stuff, and you'll get usually some pretty good answers, to be honest. But this will be the definitive. This is how you know if you are right or wrong. Are you in agreement with this document? Yep. Yeah, and as we start talking about more protocols, I'll link the RFC as we get to them. So any internet protocols specifically use RFCs. Yep.
We're talking about HTTPS. Is that like the same thing as HTTP? As far as
yes and no. From our end, it's mostly the same, but HTTPS adds a layer of encryption on top of it, and that goes right in between the TCP socket and our HTTP server. So for our purposes, we write servers as HTTP servers, and then slap a layer of encryption on top of it and call it HTTPS. So when you're building web apps, you usually don't worry about the security until you're ready to deploy and add that layer on top of it. You don't write two different servers for that. Yeah.
So you said there's like get, post, delete. Are those just for humans to understand? Because if you
Yes.
slash hello, it's like, you know what I mean?
Yeah, exactly. And that took me a while to understand. So the question, just in case someone didn't hear, get, post, delete, put, those different HTTP request types, are those just for humans? And the answer is pretty much yeah. There's no magic in there. There's nothing really in the protocol that says anything about the request types, but it helps us communicate. If you say my server responds to post requests at this path, that's communicating to the end user that you're expecting there to be some content, some body in that message being sent. If it's a put, that communicates just between humans, between programmers, to be able to work effectively. Technically, you could do everything as a GET request and put bodies in your GET request. You shouldn't, but the protocol will allow you to do that. There's nothing in the protocol that takes those as sacred, just for humans, just for developers to communicate with each other.
Because like on the browser, when you put in /hello and it sends that request to your server, you have to anticipate that /hello as either get or a post on your end, right?
You'll read if it's a slash, a get or a post. And one place where that really comes in handy is if you have the same path that takes multiple request types. So you might get a get request for /hello and a post request for /hello and treat them differently. So it's a good way to be able to have one resource on your website that users can interact with different verbs by changing the request type.
So does Google automatically
That'll depend on the JavaScript of the web page. That'll decide what the request type is. So when you write the front end of your web page, you'll say when the user clicks this button, it's going to make a post request. This button is going to make a get request. This button's going to make a put request. This button's going to make a delete request. It depends on how the app is built. And typically, yeah. When you're getting the initial HTML, it's going to be a get request. Technically, it doesn't have to, but I don't see a reason why it wouldn't. And if you're typing in here, this will always be a get request if you type in the address bar, if that's what you mean. The question in chat, will we have everything for the homework before it's due? Yes. So the course website is broken down by the 4 homework assignments. So for this first section, static site, this is all the homework 1 content. And then right here, the homework 1 content ends. Technically right here, and then the last day is just examples, so we have a buffer day. But after that, the content for homework 2 starts. And this is all the content for homework 2. And the homeworks are due 1 week into the next homework's content. So you have a 1 week period after all of the content ends to finish up your homework. Obviously, you should be doing the homework throughout those 3 weeks, but you do have an extra week in case it takes a week to digest that last lecture of content. Give you that extra week to finish everything up. And the whole semester rolls like that. Homework 2 is due 1 week after homework 2's content. Homework 3, 1 week after homework 3's content, etc. Except fall recess, I don't count as a week. So you kind of get 2 weeks for homework 4, but that's only if you're working over your break. I assume you don't work over your break, which is probably a false assumption, but to be fair, you should have the option to take your break as a break. I think it was control to not do a slideshow. So the RFC, that's your source of ground truth. That is what HTTP is. And if you catch me ever saying something in lecture that violates the protocol, the RFC, let me know. Give me some crap, tell me I'm wrong. Make sure you harass me a bit, and I can update my content. But everything I say should be in compliance with that. And everything you write in your server should be in compliance with that, and then you should be good to go. There's one exception that I'll talk about in this lecture even, which frustrates the hell out of me, but I'll mention that when we get to it. Specifically, sections 4, 5, and 6 are the sections that we'll talk about today. These are the sections about the how an HTTP message is constructed, and specifically in that, like the root message, and then specifically how a request and how a response is constructed. First thing I want to talk about, I'll talk about this right now, and it's my last slide, and I'll remind you throughout the semester, and I'll give you crap in office hours if you don't do this, because I mention it so many times. New line characters in HTTP requests and responses are not just /n's, they are /r/n. Don't ask me why, it's just, I think it's an artifact from the old days. Back when printers were a thing, the /r was a carriage return, which when the printer, like the actual mechanical printers where the carriage went across as you were typing, the carriage return is to move that carriage back to the left, and then the new line is moving that carriage down one. So this is how typewriters were the very early days of the internet and computers. It was not a new line, it was a carriage return new line. /r/n or CRLF, carriage return, and then line feed, you feed the paper would rotate, not the carriage going down. My motions were wrong. This is how new line characters are in HTTP requests. When you parse requests and when you send your responses, you have to have /r/n. If you just have /n, you're not in compliance with the RFC, and the browser may or may not interpret your response properly. And if you're parsing with just the /r or /n, assuming just /n's for new line characters, you're going to have a lot of trailing /r's in all of your data, and it's going to mess up your parsing at some point. You might get away with it for a little bit. It will catch up to you eventually. You're going to have these /r's just hanging out at the end of your string, so if you're checking for like string equality, it's not going to be equal to what you expect because you have this trailing /r. So something to keep in mind when you're parsing and writing responses. /r/n, CRLF, carriage return line feed. This is how our new lines are in HTTP. Throughout the entire course, this is how the new lines are, because we're using HTTP throughout the entire thing. So let's take a look at a very simple request. We got a question, Chad, I got to read quick. No, you don't need the report.txt with your homework. Just the open source reports for the project. There's no documentation requirement for the homework. There was before, I taught this class before, and I had a requirement for that. If you still want to do it, I'm not going to stop you. But I scrapped that requirement. Once I moved to Docker, that report became less useful. I used to have a report asking you to explain the structure of your server and also how to run your server. With Docker, the how to run is kind of pointless. It's redundant. You just run Docker. And how it's structured, we could usually figure out. I did hear from my TAs this semester when I said I scrapped that they were kind of sad because it helped them think about the structure of their code. So I do recommend still writing up like how, when you get a request, like how does your server handle that, and write up some documentation, which I might require again. But anyway, no, you don't have to do that this semester. So an HTTP request. This is a very basic, bare bones, simple request. Get for the path / the root path, and then every request is going to have a host header, which I don't think I have you use in the homeworks. You don't have to use that one, but it's going to be a host to tell you where this request came from. What site was the user visiting when they made this request? So for example, if they're at another site and that site is linking to your site, you can know who's linking to you for those requests. So let's break this down. First is the request line we talked about very briefly last time. Let's go a little more in depth. This is going to be 3 values separated by space characters. Spaces are not allowed in any of these values. You can't have any spaces in your path, so URLs can't have spaces in general. No spaces in the request types, and then no spaces in HTTP versions. There's no opportunity to get an extra space in here. So you're guaranteed you're looking at 2 spaces before the first CRLF. You're going to have a new line character, a /r/n right here. And before that first /r/n, you're guaranteed to find 2 spaces, which you can separate into the 3 values that we're looking at. So that's one of your first goals when you're parsing these things, is parse this request line into the request type, the path, and the HTTP version, which will always be 1.1 for this class, which is fine if you don't do anything with that. I hate saying things like that, but I ain't going to make you worry about that. The request type and the path, you have to care about those. So get these. I would parse those. The first bit of code you should write is getting those 2 values into variables, possibly named request type and request path, and decide what you're going to do based on those 2 values. Those 2 values are going to determine what you're going to do moving forward. How are you going to handle this request? By the time we get a few homeworks in, you're going to have a lot of different requests that you're going to handle, different combinations of request type and request path. You have a lot of different combinations of those, so you're going to have to figure out how, at the top level, you're going to handle that, or rather, how we're going to route those in the internet world. How are we going to route to different pieces of functionality of our server and different responses based on those 2 values right there, the request type and the request path. So extracting those is very important. For the first homework, I expect most of you will have big if blocks. Hell, even by homework 4, a lot of you will have that, where you say if request type equals get and request path equals /, then do this. Else if request type equals get and request path equals /hello, do this, etc., etc. That's fine. I do recommend doing something more sophisticated if you're savvy to that, and having some way to route. That's not a big, gross, conditional, but you'll get away with the conditional if you do it that way. Especially for homework 1, it's going to start getting hard to read as you get farther in the course, though. So I do recommend you do something more sophisticated, something more advanced. So this is going to determine what is being requested. So /, that's typically what we call the root path, but that path is going to be whatever the user is requesting, whatever that path, and as we'll see later, everything after that host and port, everything after the host and port is going to be there. So it's the path, the query string, and the fragment are all going to be in this spot right here. Right now, we're only worried about path. So if somebody goes to their browser and goes to CSE312.com/lecture, this is what the request is going to look like on our end. So this is how we can tell what the user is requesting, what specifically they're looking for. The headers are going to be key value pairs, where the key and value are separated by a colon. So here we have a header named host with the value CSE312.com. You'll have any number of headers here. I only have one shown right here. But headers, this is something I strongly, strongly recommend. Write code that gets all of these headers into some key value stored data structure on your server. I know I said this before, and I'll say it again. I strongly recommend doing that for homework 1. Do it right away. It will pay off in later homeworks. You don't want to be messing with parsing headers on homework 4, which I've seen so many students do. They come to office hours and they're like, I'm not sure how to get the cookies out of my headers. Well, it's because you never wrote header code earlier in the semester, header parser code. So now instead of working on homework 4 content, they're working on homework 1 content, and in office hours saying, so I separated by the colon, what? Don't do that. Don't be that person. Write some code that takes the request line, parses it by looking for that first /r/n, and then separating the rest of the headers, the rest of the header, which is the headers, by /r/n, splitting by colon, getting rid of extra white space. The RFC says this space may or may not be there. So if there's a space there, get rid of it. And put all those in some key value structure. If you have, if it's Python, throw it all in a dictionary. If it's JavaScript, throw it in an object. If it's Scala, throw it in a map. If it's Java, throw it in a map as well. I forget what Java uses as default, some type of map though. But get it in that key value store. Don't be parsing headers for the first time on homework 4. Please, please, please. Homework 4 is the first one where we do some really advanced header parsing when we have to parse cookies. Don't be writing that code on homework 4. There's enough to worry about with homework 4. And then response is going to be very similar format. The first line is the only thing that follows a different protocol, a little bit different structure. So the response, the first line, the status line, is going to tell the user something about, some meta information about the request, like basically, how did it go? Here, we're following the same structure. The HTTP version comes first, followed by a space, followed by the status code, which is a 3-digit code telling the browser how things went down, followed by a space, followed by the status message, which is a human-readable interpretation of the status code, just so for our benefit, so we can read it. This, unlike the request line, this can contain spaces. So this code can contain spaces. There cannot be spaces in the first 2 values, so the browser is going to parse by looking for the first space. Everything before that's the HTTP version. Everything between the first space and second space is the status code. And then everything after the second space, including any subsequent spaces, is going to be the message, the human-readable status message. So we can have spaces in there. There are standard messages, human-readable messages for each error, for each status code, and you should follow those. But technically, the browser, the protocol, doesn't really care about those. Things will work if you miss those. So for example, if you miss your capitalization, if you do lowercase OK here, it's going to be fine. The browser's not going to complain to you. That's only made for human benefit, so the code in the browser isn't going to care about that. If you get the status code wrong, that's what the browser's reading. That's going to mess things up if you have the wrong status code. But the human-readable part, computers don't really care about this so much. You should definitely get it right. I'm just saying it's not picky enough that you need to get your capitalization, your spacing exactly right. If you have a typo in there, things aren't going to crash and burn. If you have a typo right here or right here, things are going to crash and burn. And then followed by your headers. So you're going to have to write headers. And remember, when you're writing all this, all these lines end in a /r/n/r/n/r/n. You're going to hear me say that a billion times throughout the semester. When you write your headers, these 2 are critical. If you are sending any information to the user, you have to have these 2 headers, content type and content length. These are case sensitive. These are interpreted by the browser, by the client in general. So these do have to be right. Content type, capital C, capital T with a dash. Content length, capital C, capital L with a dash. If you go into your browser, and which I highly recommend, by the way, one of the really nice things about this class is you have billions of examples out there. Just go to any web page, open up the browser console, and take a look what's going on. Sometimes you will see lowercase c, lowercase t. Whenever you see that, look at the HTTP version. It's probably not 1.1. At least it better not be, because they're not in compliance if they're not. But they're probably using a different version of HTTP, just so you know. So when you do go around to the web and see live examples, make sure you're looking at the HTTP version, because things are slightly different in the other versions. Capitalization being one of them in this case. The content type, we're going to talk about this a lot next week. For now, text/plain is fine for the content we're serving. For /hello for that path, text plain for your 404 for objective 2, text plain, perfectly fine. The content type is going to, as kind of the name implies, tell the type of the content that's being served in the body, which we'll talk about in a second. It's saying, how is that structured? Is it HTML? Is it CSS? Is it JavaScript? Is it JSON? Or is it just text? Is it an image, which we'll do for objective 5? What is it? And this is what's called the MIME type. The MIME type here, text, and then /plain. It's textual information, and it's just plain raw text. For example, when it's HTML, it'll be text/HTML to tell the browser what this content is. And then content length, how many bytes of information are being sent? This is very, very important. How many bytes of information should the browser read? This has to be exact. This, I'm sending hello, 5 ASCII characters, can be represented in 5 bytes, so my content length is 5. As we'll see next week, the content length is not always equal to the length of the string if you have non-ASCII characters specifically, which is a topic for next week, which is objective 4 in the homework. Content length that's not equal to the length of the string. So content type and content length, this is going to tell, those 2 pieces of information together are going to tell the browser what to do with the information that's being sent from your server. And finally, the information itself. What we call the body of the request or response in this case. This is where the actual content is that we want to send. Everything else, all the headers, that's just meta information about the content. Now we're finally getting down to it, the actual content. To find out where the content starts and the headers end, there's going to be a blank line. So this line and all these lines are going to end in a new line character, which is /r/n, because it's HTTP. And then we're going to have a blank line, which is another /r/n. So to separate the body from the headers, we're looking for this sequence of bytes, or this string at this point. We're looking for this string, and that's going to split the headers from the body. So when we start parsing, in a little foreshadow here, our requests that we get from browsers are going to start having bodies, content links, and content types. When you're parsing those requests, one of the first things you want to do is look for that /r/n/r/n. You know that sequence right there is right in between the headers and the body. Then you can get just the headers, parse the first line as the request line, or the status line in this case, and then parse all of your headers, and that way you know when to stop parsing headers. It's when you find that blank line, when you find this sequence. Everything after that's the body, and you should read the body until you read content length number of bytes. The browser is going to take this content length seriously. If I put content length 3 here, and you open it in your browser, you're only going to see HEL. You're only going to see 3 bytes of information, because that's all the browser's going to read, because that's all you told the browser to read. If you have content length 6, the browser's going to hang. You're going to see that loading in the top, because you're not sending that 6th byte, and it's waiting for that 6th byte. 11:10. I always got to think about when class is end. 11:10. The response codes, these are grouped into their 100 levels, where if the code, this is a 3-digit code, if the code starts with a 2, that's an everything went fine, everything's good, don't worry about it. Here's your content, enjoy. If that error code, if that status code starts with a 3, our 300 level codes, that means you got the content you want, but you might have to do some extra work or less work. Like, you're going to get to where you want to go, but you're not quite there yet. These redirects can redirect to another page, another site completely, another server, or it can say redirect to your own cache. You already have this. It's not out of date in your cache. Just use your local copy, because we got none for you, and we're not going to resend and just use up bandwidth on the internet when you already have the content there and it hasn't changed. 400 level codes means the user did something wrong on their end where they didn't get what they wanted. 404, probably the most common. 403, forbidden, you're not allowed to look at that, and a few others. to say, look, something went wrong on your end. We're not giving you what you requested for one reason or another. And then 500 level codes, the stuff of nightmares for web developers. Something went wrong on the server side. It's an error, but it's a server side error. User, from everything that our server can tell, user did what they were supposed to do, but the server didn't. The server had something wrong, something went wrong. And when you get these 500 level errors, it doesn't matter if it's 2 in the morning, like you got to fix your shit. You got to get there and get that server running. This stuff, these 500 error codes, literally stuff of nightmares for web developers. You got your live product out there to your user base, and they start seeing 500 errors. You know you got work to do. You got debugging to do. One of these that we had to do for use for Objective 2, the 404 not found. Your server should respond with a 404 response whenever something's requested that isn't part of the homework assignment. So you get a request, it's not /hello, it's not /hi, it's not /images / some image name, it's not just / the root path, it's not /style.css. I don't remember all of them, but it's not one of the paths that actually functions.js is the last one. It's not one of the ones that are required for this homework assignment. That's when you're going to send the 404. This is just like a 200 response, except you're going to put the 404 not found, and then some message for the user. A 404 response is just a regular website. It could be HTML. That HTML could contain CSS and images. You've seen the fancy 404 pages with whatever imagery that site has. It's just a regular web page, but we hit them with the 404 to let them know, hey, this isn't actually the content you were looking for. Here's a page telling you that. Try something else. Try fixing your URL that you're requesting. Yep. If you have something cute for the 404, or if you have exactly this. No, oh yeah, if you have a picture for 404, yeah, that'd be awesome. Yeah, that'd be perfectly fine. As long as it has some message that gets the point that, hey, this is a 404, we couldn't find your stuff. If you have exactly this, I might get a little uneasy. I mean, like at least like think a little bit, come up with your own message. But yeah.
For like 500 response codes, when it's the servers, like something's wrong with the server,
Mm-hmm.
is that something that the user's browser is detecting, or is that something the server has responsibility?
That's something the server is detecting, is the 500 error. So the way it works, your 404. So imagine you have your if block, if path equals /hello, else if path equals /hi, else if path equals / whatever, et cetera, et cetera. The 404 would be the else block. I'll get to your question in a minute, but I want to frame it like this. The else block would be your 404. If it didn't hit any of these paths, send them the 404, because I don't know what to do with this thing. The 500 would be wrapping that entire thing in a try-catch. So if you have some error that was thrown, you'd be like, something went wrong on my end. I don't know what it is. It's not something I have any code to address. It's just some error that was thrown somewhere along the line. You're going to catch that error and then send the 500. Which, now you mentioned, I should have that as an objective right from homework 1. But we should never see the 500s if everything's working right. So I guess we couldn't test that anyway. In 301, the other part of Objective 2, moved permanently. So this is when you're changing around your URLs. You have meetings and design meetings and everything, and somebody, as a team, you decide, okay, the way we have our paths set up, we want to change some of these. We just want to organize our paths a little better. Instead of /hello, we don't like that path anymore. We're going to change it to /hi. But other people who have links bookmarked and want to visit our site, but might have an old version of the link, we still want to keep that live. We still want that to work. For these, we're going to use a 301, move permanently, and redirect them to the path of that resource. So 301 is the code. moved permanently with a space. Spaces are allowed in the human readable codes. Moved permanently is the message for a 301. If you have a 301, you have a required header of location, which is going to be the location that you're redirecting them to. So if this is your 301, you have a request for whatever. I'll stick with the homework. You have a request for /hi. Oh, I said that backwards. /hi, you want to change to /hello. You get a request for /hi, a GET request for /hi. You're going to hit them with this. You're going to respond and send back over that TCP socket. You're going to send back the 301. Once you set the 301, send a 301, the browser will look for a location header. And it'll make another request, a second request to that location. So here, I'm sending them a location of new path. The browser's going to make a new request to that path with the same host and port combination and protocol. So if I say, if I just give like /new path like I have here, what we call a relative path, same protocol, same host, same port. So the first part of the URL, everything up to the path, is going to be identical. And a second request is going to be made for that new path. We can also do absolute paths. So if you want to redirect them using a different protocol, a different host, or a different port, or any combination of those changing, you could do that too. Location, give it a full URL, and the browser is going to follow that entire URL. So if I want to redirect people to Google, this is how I would do it. I would send a 301 back with a location of a full URL, https://google.com. This content link, this is the thing. I hate this so much. If there's no body of your response, you don't have to have content length. I read it and reread it, the RC. If somebody can find something else, some better answer to this, let me know. If you don't have a body to the response, you don't have to have content length, and the content length should be assumed to be 0. That's what the RC says. If you don't have content length, like on a 301, we're not sending any information back, we're just sending this location header back. If you don't have content length, Firefox will hang. Firefox only is the only browser I found that does this, and it causes a billion questions in office hours. And I'm like, Firefox isn't supposed to do that. It's going to hang. So on your 301s, if you put content length 0, you're going to satisfy Firefox, and Firefox is going to follow your location and move over there. If you don't have that content length 0, you're going to have, well, it works in Chrome, it works in Opera, it works in Safari, but when I open up Firefox, I don't know what's happening. And if your TA is testing in Firefox, oh man, of course we're all going to know about this, but just put your content length 0. That satisfies Firefox. Firefox is like, oh yeah, content length 0, there must not be a body. It won't assume that there's no body. And I can't figure out why. I haven't figured out a good answer for that. And a reminder, new lines are /r/n. All the new lines in that, I didn't explicitly show my new line characters throughout the slides. All the new line characters are /r/n, not just a /n. All right, let's jump to some code. So I have my server from last time, and when I'm sending a response back to the browser, let me run this. So I'm running a TCP, this is Scala code, if you're wondering. I'm using Aka's library for TCP, which is acceptable. If you want to use an external library, as long as you're using something that's like an industry standard, pull in some external TCP library. You don't have to use what's built into the language to handle your TCP. Whatever you need to do to handle TCP. Here, I'm importing TCP from Aka. And then setting it up, it works on an actor system like you saw in 116. I think probably all of you have taken the new 116 where we've seen actors in actor systems. This works on the actor system, and there are certain messages that you receive that, that will handle that message, or handle the TCP connection, I should say. The big one is received. R is an object with the data that you want to read. and then we're going to read that data and parse it and do what we want to it. I'm not doing any parsing here because I don't want to give away the homework, especially not in just one language, because then everyone using that language has an advantage. But I will give away some of the responses. Here I'm just printing the request to the screen, formulating my response, and then sending the response over the socket, over the TCP socket connection. So when I go to, let's start with Firefox. So when I go to, I forgot to point that out. I'm running this on port 8002. When I go to 8002, I get hello. And if I go to the browser, go to network and then refresh, I can see the request that was made, all the headers, all of the information, and the response. These headers were parsed from what I sent back. I sent back those 3 headers, just like we saw in the slides, /r/ns all the way, and colon, key value pairs separated by colons, and an optional space. I added my spaces here. I think it's just a little more readable. And content length that matches the length of the content. If I change content length, I meant to not do 4. Let's retry that. It's only going to read the number of bytes that I told it to read. So if I don't have content length matching the actual length of the content, I'm not going to get all of those bytes read. No sniff. That's something we'll talk about later. It has to do with the content type, but that's a topic for another lecture. The short answer is it tells the browser my content type is right. Don't assume some other content type. All right, so that's stuff we saw last time. Let's change this up a little bit and do the move permanently. I'm going to redirect users to google.com. I'm going to restart the server. I'm going to go into Opera. I'm going to refresh. And we can see the first request made was to localhost 8002. It was a GET request for the root path. And the response was a 302 moved permanently, location google.com. And then the second request is going to be a request for google.com. This one also got 301, or not also, got 301. The other one was a 302 that we've been doing. A 301, and apparently they don't do human readable messages. But let's see, location to www.google.com. Then another request for www.google.com, which gave us a 200, which actually had the content we were looking for, which will have all kinds of HTML, which looks like just a whole bunch of embedded JavaScript, and then a whole bunch of more requests to get the content loaded. All the multimedia, all the social stuff, all the login information, all kinds of more requests. If I go to Firefox and do the same thing, localhost 8002, we get nothing. I don't know why. In Firefox only, it just hangs and hangs and hangs and waits for information in the body. We do content link 0, and by the time I get back to the browser, it already got the response and redirected because it's resending and getting the new information. I don't know why Firefox does that. You just saw it work in Opera. It works in Chrome. It doesn't work in Firefox. So content link 0 to make sure you're working in Firefox. And I actually didn't think I'd get through all that. So any other questions? Yeah.
For this class, like let's say we're not using Firefox, do we still need to put it in just for? Like,
you should. I mean, it's easy enough to add in there. Just to make sure, like, if the TA happens to be using Firefox, you cut out one step for them. If it hangs, if they're using Firefox and it hangs, they got to switch to another browser. This is the one thing we would let slide just because Firefox seems to not be, there's got to be more to the story that I don't know, but I haven't been able to find anything. But it seems like Firefox isn't complying with the RFC. So that's one case where I'd let that slide. But just to make it easier on everyone, just add that content link 0, then you have no questions. It doesn't hurt the other browsers to have that content link 0. The RFC says you can have content link 0 or omit it. So it's not wrong to add that. Yep.
I'm assuming there's like a function that will tell you the length and bytes of whatever you have.
And we'll talk about that next week. Yeah, you want to convert the string to bytes and then get the length of it is going to be the answer there.
And the file,
Yep. Files are actually easier, as we'll see.
do you just pass the file or do you have to parse the file for string?
We can just pass it. We'll talk about that next week, though. Yeah, files are actually pretty easy. Yeah, one more. I won't, but you can watch it on the video and copy it over. All right, with that, I'll see everyone Friday.